Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 12 mathematics, and in this video we will have a look at double angles. So if you've watched the previous video on compound angle identities, this is basically a continuation of it. If you have not seen the previous video yet, I would highly recommend that you go check it out so that you have a proper understanding, because compound angles and double angles, they work hand in hand in grade 12 mathematics. So we will have a look at an introduction to what double angles are, why do they exist, what do we use them for, how to use them. Then we'll have a look at the double angle identities for cos as well as for sine. Without any further ado, let's get into it. So as we've mentioned in the previous video, that in grade 11 you were introduced to reduction. And we said reduction is the process of taking a big angle, and making it smaller so that you get the same answer at the end of the day. But the focus of this video is not really on reduction, but it's good to know that reduction does exist, and to a certain extent we're going to make use of it when doing double angle identities. We've said that reduction is useful when we're working with numbers which are multiples of 90 degrees. For example, 180 degrees, that's a multiple of 90. 360 degrees, that's a multiple of 90. If you have something like cos of, let's say, 45 degrees minus x. If you've watched the video on the compound angle identities, you would know that we can expand this. We cannot use reduction here, but instead we could say this is cos of 45 degrees, cos of x plus sine of 45 degrees, sine of x. And you would know that 45 degrees is a special angle. In both cases, you can write this as something like the square root of 2 over 2 cos x plus the square root of 2 over 2 sine x. But anyways, this is not the focus of the video. This is beyond the scope of this video, as we've covered this in the previous video. You were also taught that sine of 2 theta is not the same as 2 sine theta. To prove this, I know that sine of 2 times 45 degrees is the same as saying 2 times 45, this is a sine of 90 degrees. Now sine of 90 degrees as a special angle, this is 1. But if you had to press 2 sine of 45 degrees on your calculator, this is going to be 2 into sine of 45. This is a special angle, so we get square root of 2 over 2. The 2's will cancel out and you remain with the square root of 2. So you can see that by doing this, we have proven sine of 2 times 45 degrees is actually not equals to 2 sine of 45 degrees. You could do the same thing with cos 2 theta. You would see that cos of 2 theta is not the same as 2 cos of theta. The same with tan of 2 theta. It is not the same as 2 tan of theta. So let's look at a scenario where we're given cos of 2 theta. This is known as a double angle. Why double angle? Because the coefficient of the angle is an even number. Does not necessarily have to be 2. As long as it's an even number, meaning as long as it's divisible by 2, it is a double angle. So to simplify cos of 2 theta, we could use the identity cos 2 theta is equals to cos squared theta minus sine squared theta. And the same identity, we can write it as 2 cos squared theta minus 1 and 1 minus 2 sine squared theta. Now there's actually a process behind how we get this identity using the compound angles, but that's beyond the scope of this video, so we shall not cover that. The same applies with how to get the other two identities for cos. So basically what you need to know is that we've got 3 double angle identities for cos, and you need to know all 3. They will be provided in the information sheet, but it's good for you to know them because you might need to use one over the other in circumstances where you need to prove a specific identity, or where you'll have to do general solution. We'll have a look at general solution using compound angle identities and double angle identities in another video. Let's look at our first example. The question says you need to rewrite the following as a single trigonometric ratio. So we're given sine squared x minus cos squared x. Let's go to the writing pad. We have here sine squared x minus cos squared x. When you look at this at first glance, you'll think to yourself, woohoo, double angle identity for cos. But let's wait a second and let's go back to our notes. We said our double angle identity is cos squared theta minus sine squared theta. Yet the question we're given is sine squared x minus cos squared x. So let's just write this down on the side. Our double angle identity for cos of 2 theta. This is supposed to be cos squared x minus sine squared x. And in the question here, I've got the total opposite. To solve this, what I can do is I could take out -1 as a common factor. When I take out -1 as a common factor, I'm going to get negative sine squared x plus cos squared x. I could swap these two around and have negative cos squared x minus sine squared x. From our double angle identity, we've got cos squared x minus sine squared x. We've got cos squared x minus sine squared x. We can replace this with minus cos of 2x. There we are, we have simplified the question. Life is great. Let's look at the next question. So, we've got 1 minus 2 sine squared 15. Right, let's go to our writing pad and let's have a look at this. So, let's write this down. You've got 1 minus 2 sine squared 15 degrees. Let's quickly go back to our notes again and see whether the identities that we have actually match. We've got 1 minus 2 sine squared x just there, so we can actually use that identity. Let's go back to our writing pad and I'm going to include it up here. I'm going to say, okay, this is also 1 minus 2, it's a 2, sine squared x, and let me put the other identity there while I'm at it, 2 cos squared x minus 1. So, I am using this identity for the question that I'm looking at now. So I could say, okay, this is going to be sine of 2 times 15 degrees. Now, 2 times 15 is going to give me sine of 30 degrees. I'm going to leave my answer right here because the question said we need to simplify as a single trigonometric ratio. But we know if the question didn't specify that, we would have pressed sine of 30 degrees on the calculator. And because 30 degrees is a special angle, we were going to get an answer of 1 over 2. But that's not applicable here because the question said we need to leave our answer as a single trigonometric ratio. Brilliant. Let's look at the next question. You've got 1 minus 2 cos squared 2 theta. I like this one. So, you have got 1 minus 2 cos squared 2 theta. Let's scroll up and look at our identities. We do not necessarily have an identity that matches. Our question has 1 minus 2 cos squared theta. Our identity has 2 cos squared x minus 1. So once again, just like what I did in the first question, I could take out minus 1 as a common factor. Then I remain with minus 1 plus 2 cos squared 2 theta. When I do this, I can swap the two terms and I get 2 cos squared 2 theta minus 1. Now, we said 2 cos squared x minus 1 up here. This is the same as cos 2 theta. That's our double angle identity. So I could say this is negative cos of 2 times 2 theta, which will actually give me negative cos of 4 theta. There we are done. Life is great. I hope you guys are understanding this. I hope it makes sense to you, and I hope that you're enjoying it. If you are enjoying it, please give us a like. Please subscribe to the channel. Click on the bell icon so that you can get notified every time when we upload new content. Anyways, let's proceed to the next question. Right, this question wants us to calculate the following without the use of a calculator. So we've got 2 sine squared 15 degrees minus 1. Let's go to our writing pad. So we've got 2 sine squared 15 degrees minus 1. When we go up to our identities, you will notice that the identity that has sine is this one right here. But this is 1 minus 2 sine squared x, and the question has 2 sine squared 15 degrees minus 1. Once again, let's take out -1 as a common factor. We're going to get -2 sine squared 15 degrees plus 1. Once again, we could swap the terms in the bracket and get 1 minus 2 sine squared 15 degrees. When we simplify this, What we have in the bracket is a double angle identity for sine. So this is going to be negative sine of 2 times 15 degrees. Now 2 times 15 degrees, this is going to give us negative sine of 30 degrees. Sine of 30 degrees, this is going to be negative a half because this is a special angle. Wonderful. Life is great. Now let's move on to the next content. Now we're looking at the double angle identity for sine. And what's going to happen is we've got a single identity. There's only one identity for the sine double angle. As we said, unlike cos, we've got one identity for sine 2 theta. We do not have a double angle identity being tested in grade 12 for the tan trig ratio. In the same way, if you've seen in the previous video, we did not cover the compound angle identity for tan. Although it does exist, it is not covered in the grade 12 syllabus, so we need not concern ourselves with it. Right, let's look at some questions here. We are rewriting the following as a single trig ratio. Right, let's go to our writing pad. Let's open a new sheet of paper. The question we are dealing with is 2 sine 2x cos of 2x. Now once again, let me write down my double angle identity for sine right there. So sine of 2 theta is going to be 2 sine theta cos theta. There's only one identity. And that's exactly what we have here. We have a matching pattern. So I can say this is going to be sine of 2 times 2x, which is actually going to give me a sine of 4x. There we are done. Life is great. The next question. So in the next question, we've got 2 sine of x plus 30 degrees, cos of x plus 30 degrees. Let's go to our writing pad and do this. So 2 sine of x plus 30 degrees, cos of x plus 30 degrees. Now this is a double angle identity because I've got the 2, which is there as well. I've got sine, and sine is present in our identity. We've got cos here, cos is there. Our angles are the same, x plus 30, we've got matching angles. So I could say this is the same as saying 2 sine of 2 times x plus 30 degrees. And when we simplify this, we are going to get 2 sine of 2x plus 60 degrees. And for those of you who don't understand how I did this, basically I multiplied 2 times x, that gave me 2x. Then 2 times 30 gave us 60 degrees. And there we are, we have answered the question. Right, the next question wants us to show, without using a calculator, that 2 sine 75 degrees sine of 15 degrees is equals to a half. So let's go onto our writing pad and let's try this out. So let me open up a new sheet for some extra room, if my devices would allow me to. So we have got 2 sine of 75 degrees sine of 15 degrees. We want to prove that this is equals to 1 over 2. So I'm going to work on the left hand side. On the left hand side, we've got 2 sine of 75 degrees sine of 15 degrees. As this equation currently stands, we cannot use the double angle identity for sine because, first of all, our angles are not the same. Secondly, we've got the same trig ratio. Remember that identity again. Sine of 2 theta is equals to 2 sine of theta cos of theta. So let's see what we can do here. I can say, let me leave the 75 degrees as it is. Then for sine of 15, I'm going to say, let's make the angles equal. So 15 degrees is the same as saying 90 degrees minus 75 degrees. Once I get here, this is going to be 2 sine of 75 degrees. From reduction, we remember that sine of 90 minus that's in the first quadrant, all trig ratios are positive in the first quadrant. But because we are dealing with 90 and 270, the sign changes to cos. So we've got cos of 75 degrees. This is actually the double angle identity for sine because it matches what we have up there. So I could say, let me write this as sine of 2 times 75 degrees. This is going to give me sine of 150 degrees. Now this angle is greater than 90 degrees, so we could do reduction. This is going to be sine of 180 degrees minus 30 degrees. Now 180 minus is in the second quadrant, sine is positive in the second quadrant, so this will give me positive sine of 30 degrees. 30 is a special angle, so this is going to give me 1 over 2, which is exactly what we have on the right-hand side. We have proven the identity, or we've proven that 2 sine of 75 degrees sine of 15 is a half. Wonderful. Life is great. I hope that you guys enjoyed this video, that you enjoyed the content, and that you learned something about double angle identities. If you did, please give us a like, please give us a thumbs up, subscribe to the channel, click on the bell icon so that you never miss an update every time when we release new content. Until then, do enjoy the rest of your day. Ciao.